So, the blue team. Hi everyone. Today I will be giving a talk, AI in Defense, finding high value automation across the blue team stack. Um, so, my name is Adelia Ibragimova, and I'm security engineer. I work for EPAM Systems, that a global consultancy and a product development company, and I'm currently focused on developing AI-driven solution for MSSP environments. So this talk will cover how to integrate AI into SOC, into Security Operations Center. Let me quickly walk you through what this talk will be about. So we will set the stage with AI theory foundation. I'm not going to dive deep into academic stuff, but just little focus. And then we will move to detection rule creation and translation section. And here I want to show how we need to automate AI and by using AI translation for detection, creation, and translation. Then we will move to detection log analysis section. So there is AI, I think, becomes more really interesting because everybody knows that machine learning is strong at spotting anomalies statistically. But while LLMs brings interpretation and a context. So I will share you how we could combine these two approaches. And finally, I'm gonna cover tier 1 automation. So tier 1, that is a part of Security Operations Center. And people find this job the most exhausting. So because of endless alerts and repetitive stuff, checks and tasks. So, and here I want to show how we need to use AI agents just to offload this work. AI theory foundation. We could broadly categorize AI approaches into four fundamental types. So RAG systems. RAG systems are class of AI solution that combine generative model with retrieval over trusted sources to deliver answering grounded up-to-date facts from both internal and external data. So RAG systems combine corporate knowledge base and threat intelligence feed to generate fact-based detection rules. And we have supervised models. That is a classical machine learning part. So supervised models use gradient boosting, classification, and anomaly detection, but on label datasets. So supervised models rely on labeled datasets and typically use techniques like gradient boosting and classification. AI agents. AI agents, data system that wraps an LLM with a state, tools, and policies. So it can perceive, decide, and act towards a goal iteratively and autonomously. So for AI agents could be we could use for Security Operations Center as a copilots. So these copilots actually could do automating triage, enrichment, and correlation tasks. And LLMs, of course. So modern LLMs like Llama, Mistral, GPT class models, they could build in the Security Operations Center as universal automation layer. Let's start with detection, rule creation, translation. So before diving into solution, let's be honest about the problems we face in Security Operations Center today. Adopting best practices is slow. So rules from communities, detection rules from community and from vendors often use a different syntaxes. So instead just of reusing them, analysts spend hours to adopt them. So that slows down the adoption of best practices. Then it goes so analyst time is wasted. So here, highly skilled expert often end up with rewriting queries instead of just focusing on actual detection logic or improving coverage. Then it goes inconsistent detections. So without translations, the translation of detection rules, so the same detection pattern can look different across tools. So that creates blind spots. One CM might flag an attack, another CM just could miss it completely. And that is and finally, all of this lead to vendor lock-in. So detection logic tied to one CM platform, which makes migration long-term flexibility much harder. What the best approach to address this problem? So that's an evolution. The answer is not just LLMs, right? So that's about evolution from LLMs to RAG and then to finally to RAG agents. So how this evolution happens. So LLMs are powerful, right? So, but they're not enough. So, because they can hallucinate and they don't know SOC-specific syntax. So, and there the RAG comes in. So, the retrieval augmented generation allows to bring in the field mapping and syntax example from index sources without retraining model every time. So, with the retriever finds the right chunks and the LLMs organizes them, and they get structured fact-based output. From RAG to RAG agents. So, but the real breakthrough happens when the add agents. So, RAG agents go beyond just retrieving information. They validate syntax, they understand SOC context, and they can even trigger a real-world action. Like updating detection pipeline or pushing a new detection rule into production. So that's the step from passive assistant to autonomous detection engineering. So here I want to cover a real possible architecture of agentic RAG AI rule translation from YARL. The key moment here is a doc search that starts from this part. So instead of single retriever, system using a tooling arsenal of specialized instruments, as usually agents do. So security document retriever searches official UDM documentation and correct field mapping. GitHub rule finder. So on this scheme, that just GitHub on the in the blog. So the GitHub rule finder identify examples of detection rule, and then the Google rule validator check syntax and production compatibility from the official API and the field converter tool. So handle precise information between SPL, KQL, or YARL queries with multi-layer fallback strategy, just to guarantee valid results. Tools are selected dynamically depending on the context. So, for example, SPL or KQL and supported by semantic search that automatically categorize the detection roles. If it goes AWS, Microsoft, and etc. for more accurate matching. And together, all of these instruments ensure that agent doesn't just generate, but it retrieves, validates, and deliver output. Yes. And act as professional production grade quality level. How we solve this problem? So that they have they build a RAG agent So we shipped a production rack agent that use a hybrid retriever and agentic plan to detect the source CM. So that is not just detect the source CM, that translate to a target and validate via API. So it runs in GCP and Azure as a scalable pipeline that converts a large batches of roles into production-ready output. So there is a link, guys, that you could just try to scan. You will find an article that I was an author of this article. Yes, there's supposed to be like thorough details, so please just follow, and you will find this article with our rec translator. Yeah, so we could move. But again, we still have pros and cons in this concept. So the pros, again, is that is speed, consistency, quality, reuse, maintainability, governance, knowledge growth, lower manual load. But again, the cons is that is could be semantic gaps. They still have we still have a corpus dependency. They still have a tooling feed and etc. Detection log analysis. Again, really interesting part here. So the main problem that we have if we would like to work with detection that is unstructured or noisy logs, that is again time-consuming investigation, that is real lack of correlation across sources, and that is high false positive rates because of insufficient filtering leads to alert fatigue. Yeah, and then the most vendors talk about AI for detection and log analysis. The default answer is machine learning approach. But there is a problem. They all seen by now that user and entity behavior analytics, probably everybody knows about this user and entity behavior analytic approach for anomaly detection, but it didn't live up to promises. So it tends to still generate high false positive rates. It still has lack of necessary context for analysts to make a decision, and it doesn't adapt quickly enough for evolving threats. But because it's still a machine learning approach that definitely does shine in certain areas. So that means it very good at finding anomalies in large volumes of structured numeric data. So it builds statistically baselines, clusters, and applies time series models. And yeah, so but if you're monitoring network flows or login patterns at scale, machine learning approach is incredibly effective. But we understand that this machine learning alone is not enough, and LM alone aren't precise. So the answer is just combining them. So again, I was talking about the strength of machine learning. So it's great at a scale. It isolates outliers, detects signal spikes, and spots rare behavior and structured data. But machine learning still struggles with a context, and that's where LLM comes in. So LLM can interpret cluster and explain machine learning outputs by using logs, playbooks, and business context. So they add explainability and precision. So they tell you not just that using logs that something is unusual. That's why it might matter. And here a possible architecture. So here was the full detection pipeline looks like. Then they bring machine learning approach and LLM. Here, the example that was GCP based. So, and later I'll explain why the GCP cloud was chosen. And on the example, and everything happens with example of crypto checking log analysis. Yeah. So that's a good example also for investigation AWS logs. So that was really happened. So that was a crypto checking incident happened. And for example, if we have logs or if we intentionally generates logs for crypto checking practices, that was just an example with AWS Cloud. So because of that, we have as a data card duty logs, CloudTrail flow logs, and all of these logs go into BigQuery, be it pub and sub and data flow. Yeah, and here, future engineering. So from there, they generate hours, aggregates, counts, DNS, and IP lookups, hits or missing images. Then it goes machine learning detection layer. So in this case, that is a Vertex AI. So machine learning models we could use like isolation, forest, or profit, or any clustering models for analyzing such logs. Then they also could combine these machine learning approaches, any machine learning models. We could combine them with LLM layer. That's the better approach is using RAG in this context, not just LM, that is RAG that enrich each candidate. So because we still have a context, and this output, the result written back into alerts table in a BigQuery and then routed to the, in this case, to Chronicle. So that is possible architecture, mostly about the GCP cloud approach again, but and here the reason why. So if we decide that's from my point of view, and if then I was doing the research, for my case, nothing beats Google BigQuery ML plus Vertex AI, because they still have SQL first ML that comes from GCP. We could work with seamless RAG on BigQuery logs with Vertex vector search. And here on the next slide, there is a good table competitive view on machine learning services. So there is a comparison between Azure, AWS, and Google. Here we have log ingestion, anomaly detection, triage, reckon logs, and from my side again, the best approach if you want to if you really want to completely customize your machine learning approach plus LLM, it's better to go with GCP cloud because of the services, because of the BigQuery, and especially if you want to work with pipelines, it's still better just to use GCP cloud for this case. Here, price overview. Yeah, so, and again, they still have pros and cons, this approach. Again, pros, that is speed, that is scalability, flexibility, that is continuous learning, because we can use models, improve them over time with feedback and retraining. Automation enables automated triage and enrichment of log events. But we still have these cons. So the cons, again, they are trying to analyze logs, and they probably could be sensitive ones. So data sensitivity, LM may process sensitive log and raising privacy and IP concerns. That is a false positives explainability. So sometimes complex models may produce results that's just hard to interpret or just justify. And again, so the main cons, that is security risk here. Tier 1 SOC automation. So the problem statement that they have, that is alert fatigue, skill bottleneck, inconsistent triage quality, and SOAR. SOAR is static. So alert fatigue. So analysts drowning in repetitive log value alerts, as I mentioned. So that the most exhausting job for analysts, that's a tier 1. So that is inconsistent triage quality, and from my side also that the main problem that is SOAR is static. So traditional SOAR platforms don't really solve this. So they really on predefined playbooks. They struggle with new or willing threats, and the results a system that can automate the past, but not adapt to the future. Agents. So here again, the best approach to resolve this problem is agents. So multiple agents can take specialized roles, triage, enrichments. And if we really talk about AI agents, the best thing here is that agents could really act as security operation team. So instead of one giant model making every decision, we orchestrate multiple agents, and each agent does its part. So together that function like an AI-powered SOC team. So the results is scalable, reliable, and much closer how a real team works. Yeah. But from my side, the problem here, this approach, again, that because they couldn't rely on the agents as a SOC team completely, because they still need to have a feedback loop. We need to monitor them. We need to monitor them. And here is a possible architecture of this approach. So that all happens from ingestion. So we start with alerts that coming from CM platform. They enter the pipeline through a message bus, probably a queue. Then it goes triage agent. So the first agent in line is usually a triage agent. Then it goes enrichment agent. So the agent pulls in the context that use threat intelligence, asset data, user info, and everything analysts usually have to fetch manually. Then it goes decision agent. With enriched alerts, the decision agent evaluate what to do, escalate or suppress or after close. And this decision agent, from my side, the most sensitive one, because there is on the better way to work with decision agent just to have end-on core mechanism, because we need to control the age isolation step until I've never seen in practice that decision agent was completely autonomous agent. Every time that usually works with end-on core approach. Case agent escalation agent, that is if the alert is valid, a case agent creates the ticket with a full context. And the final step, that is a feedback knowledge base. So from there, analyst feedback loop back into knowledge base, metrics and dashboards and track performance. So it all goes to the ticket and to the knowledge base. We still have here also pros and cons of this approach. So the pros are at the speed, that's quality, much better sometimes, that the consistency, maintainability, that knowledge growth, that governance. But the main cons still are, again, that is corpus dependency, semantic gaps, and it's false confidence, and sometimes that is drift upkeep, And again, security API, Central KBA may expose sensitive detection of heat license issues. Here, the good schema that really shows us how SOC code looks like. Especially, I do like this alert triage and incident response part. Here you can see the alert triage agent, investigation agent, and incident response agent. They in one block. So we still need to have context enrichment. We still need to have SOC analysts that will control these agents. And again, there is no way to automate this agent without any feedback loop. Yeah, guys, do you have any questions? Mhm. Um, so I really like this question. Probably everybody knows about profit teams and our vendors that provide security automation solutions. And the problem is, mostly of vendors or security automation mostly focus on tier one. And the answer is because it's easier just to handle the context about the alert, because the tier two usually focuses on not just covering all information. They more focusing on isolation, suppressing with real world actions. And here, the real problems, there is no way to have absolutely autonomous agents. We still need to have analysts. That's kind of end-on-court mechanism approach. And that's a real problem. So that's really hard for vendors or for products explaining people like, yeah, okay, you can use this automation, but we still need your analyst. And there is a lots of problems, concepts, and questions that still SOC operations still just trying to figure out how we could use this automation in tier two, because we still working with sensitive logs. We still need to think about how we could integrate AI, especially if we talking about like integrating not supervised machine learning that was built on the sensitive data that's more secure. Then if we think about any open source models or famous GPT class models, if you want to integrate them, that's again lots of questions, pros and cons. Yeah, I'm sorry. Probably answer for a question. Yeah. Guys, do you have more questions? Okay, thank you for your attention. It was a pleasure to be here.